Based on the heading, we can divide the chapter into two: seasons and time for our easy learning process. Let's discuss the details of seasons first. What is season? It is a division of the year marked by the changes in weather, ecology, and the amount of daylight, which means variation in the amount of the sunshine is the fundamental feature of season. What is the reason for the change of seasons? That is very important for understanding the details of seasons. First reason is the Earth's revolution. Second, tilt of its axis. And the third is parallelism of the Earth's axis. In an elliptical orbit that the Earth revolves around the Sun, it is known as revolution. The axis of the Earth is tilted or inclined at an angle of 66.5 degree from the orbital plane and 23.5 degree from the vertical plane. This is the tilt of axis or the inclination of the axis of Earth. The third reason for the change of season, that is the parallelism of the Earth's axis. The inclination or the tilt, what we have noted earlier, the Earth maintains this throughout its revolution. That phenomena is known as parallelism of the Earth's axis. So there are three reasons for the change of seasons: Earth's revolution, tilt of the axis, and the parallelism of the axis. Look the picture. We can easily find the 23.5 degree of the from the vertical plane, that's 90 degree, and the 66.5 degree tilt from the orbital plane. Orbital plane means the plane where the orbit of the Earth lies. Due to the parallelism of the Earth's axis, the position of the Sun in relation to the Earth varies apparently between Tropic of Cancer and Tropic of Capricorn. This phenomena is known as the apparent movement of the Sun. Movement of the Sun we feel so because the sunlight vertically reaches between Tropic of Cancer, that is 23.5 degree north, and the Capricorn 23.5 south. Generally 0 degree latitude is known as equatorial line, and 23.5 degree north is Tropic of Cancer, and south, that is Capricorn. Look the picture. It describes the apparent movement of the Sun due to the inclination of axis. In March 21st and September 23rd, sunlight vertically reaches on the equatorial line. In June 21st, it is in the Tropic of Cancer, and December 22 on Tropic of Capricorn. From the picture, we can find the fact that the sun's rays fall vertically over one hemisphere during one half of the year, that is on northern hemisphere from March to September, and southern hemisphere on September to March. The temperature will be higher over the places where the vertical rays of the sun fall and lower where it was slanting. This apparent movement of the sun due to the inclination of axis is the reason for the occurrence of seasons. Seasonal changes are very obvious in the tropical regions due to the large amount of sun's rays throughout the year. Tropical region means the region between Tropic of Cancer and Tropic of Capricorn, or the low latitudinal regions. Welcome to the second part of SS Second. As we have learned in the first part, seasons occur due to the apparent movement of the sun between Tropic of Cancer and Tropic of Capricorn. The apparent position of the sun will be over the equator on March 21st and September 23rd. The length of the day and night will be equal during these days on both hemispheres. These days are called equinoxes. March 21st and September 23rd is generally known as equinoxes because due to the apparent position of the sun over the equator, both the hemispheres experience same length of day and night. From 21st March, the sun moves apparently towards the north and reaches over the Tropic of Cancer on 21st June. This day is known as summer solstice. On this day, the northern hemisphere experiences its longest day and shortest night. June 21st is known as summer solstice. The feature of the day is the northern hemisphere experiences its longest day and shortest night. From September 23rd, the sun moves towards the south and reaches vertically over the Tropic of Capricorn on 22nd December. This day is known as winter solstice. On this day, the northern hemisphere experiences its shortest day and longest night. December 22nd is known as winter solstice, and the northern hemisphere experiences shortest day and longest night. Look at the picture. It was given earlier, but now I added some more details. This is the seasons of northern hemisphere. It is a ready reckoner to get more explanations. From this picture, we can easily find June 21st. Look there, June 21st. It is known as summer solstice. And December 22nd, that is winter solstice. March 21st and September 23rd are generally known as equinoxes. Between 21st March and 21st June, Northern Hemisphere experiences spring season. These are the features of the spring season. One, it is the season of transition from winter to summer. Second, the plants sprouting. Third, mango trees blooming. And the fourth is jackfruit trees bearing buds. These are the features of spring. Look the picture again. From March 21st to June 21st, Northern Hemisphere experiences spring. I have noted there SP. During this time, Southern Hemisphere experiences autumn. That's noted opposite to SP. Look the picture again. From June 21st to September 23rd, Northern Hemisphere experiences summer, which means Southern Hemisphere experiences winter, that is given opposite in the chart. It is autumn season in Northern Hemisphere from September 23rd to December 23rd. I think you can imagine what happens on Southern Hemisphere. There will be spring because it is the opposite to autumn in the given picture. We should face one more question in the autumn season, that is the features of autumn. One, the atmospheric temperature decreases. Second, shortening of day and the lengthening of night during this period. Third point, the trees generally shed their leaves. From 22nd December to 21st March, Northern Hemisphere experiences winter season. It is very easy to find what happens at the Southern Hemisphere during that time. A table is given. From the table, we can understand the features of seasons. It is very easy to learn from the picture I have given. The northward movement of the sun sets from the Tropic of Capricorn on December 22nd and reaches on Tropic of Cancer on 21st June. The northward apparent movement of the sun from Tropic of Capricorn to Tropic of Cancer is termed as Uttarayanam. During this time, the northern hemisphere experiences longer duration of day. Sun sets its southward apparent movement from Tropic of Cancer on June 21st to the Tropic of Capricorn and reaches on 22nd December. This southward apparent movement of the sun from Tropic of Cancer to Tropic of Capricorn is known as Dakshinayanam. Look the picture again. From March to September, as the sun is in the northern hemisphere, the north polar regions, which means the 80 to 90 degree latitudinal regions, experiences continuous daylight for 6 months. It is very interesting to find out what happens at the southern polar regions during this period. Listen the picture again. From September to March, the sun is in the southern hemisphere. During the period, north polar regions experiences continuous night for 6 months. And what happens on the southern polar regions? This is the second part. Thank you. Thank you very much. Welcome to our third session, a rotation and calculation of time. We learned in the previous part the revolution of Earth. The Earth moves in an elliptical orbit and revolves around the sun. During this time, the Earth rotates on its axis, and that results in the occurrence of day and night. You have already learned in your lower primary classes that day and night occurs due to this rotation of Earth on its axis. We must learn the three fundamental features of this rotation. One, the Earth rotates from west to east. Second, it takes 24 hours for one complete rotation. The third point is, as the sun rotates from west to east, the sun rises in the east. In the ancient period, time was calculated on the basis of the position of sun. The time estimated at each place based on the position of the sun is termed as the local time. Let me one more. What is local time? The time estimated at each place based on the position of the sun, that is termed as the local time. Since many of our family members are overseas, we can easily find the time difference. In the last part, we have discussed the latitudes. 0 degree latitude, that is known as equatorial line, and 23.5 degree north latitude is Tropic of Cancer, and 23.5 degree south is Tropic of Capricorn. For calculating time, we must take the consideration of longitudes. As the angular distance of the earth is 360 degree, we will get 360 longitudes if we drew one longitude each for each degree. Earth takes 24 hours to complete a 360-degree rotation, which means it takes 1 hour to complete 15-degree rotation. And it also means that Earth takes 4 minutes to complete 1 degree rotation. It is very interesting to say like this: 15-degree longitudinal area of the earth passes by the sun within a period of 1 hour. As the earth rotates from west to east, time advances towards the east and recedes towards the west. The 0-degree latitude is known as equatorial line. The 0-degree longitude is known as Greenwich meridian because it goes through Greenwich, the place where the Royal British Observatory is situated. So it got the name Greenwich meridian. The worldwide time is calculated based on this Greenwich line. So the line is generally known as prime meridian. Greenwich line is known as prime meridian because the time worldwide is based on this Greenwich line. The local time at the prime meridian is known as Greenwich Mean Time or GMT. The local time at the Greenwich line is known as GMT or Greenwich Mean Time. Based on the Greenwich meridian, the world is divided into 24 zones with 15-degree longitudinal distance and the time difference of 1 hour. These are known as time zones. To overcome many life related problems, the local time at the longitude that passes through the middle of a country is selected as the common time for the whole country. The countries with large longitudinal extent have more than one local time and more than one standard meridian. The local time at the longitude that passes through the middle of a country is known as standard meridian. The local time that standard meridian is the standard time of that country. The longitude is known as, the basic longitude is known as standard meridian, and the time there is known as the standard time of that country. The longitudinal extent of India is from 68 degree east to 97 degree east. So the middle longitude is 82.5 degree east. This is fixed as the standard meridian of India. The local time along this longitude is generally considered as Standard Time of India or the Indian Standard Time, that is IST. You might have noticed that the all longitudes except one are straight lines. What is the reason? 180 degree longitude is a curved line. Why? Look the given picture. If 180 degree longitude passes through a country, the places situated east and west of this line will be having two different days. Look at the picture. The left or west of the 180 line is 10 p.m. on Friday, and the right or the east of 180 degree is 10 p.m. on Thursday. If a person crosses the line, what happens? To avoid this, certain necessary adjustments have been effected in this line, with the result of that it does not pass through the corresponding land areas. Thus, it was curved and passes through the ocean. This imaginary line is known as the International Date Line. Go through the features given. Let's fill the worksheet given. It is the time for calculating time. The longitudinal difference between India and Greenwich is 82 degree and 30 minutes. Time difference of 15 degree longitude is 1 hour. So 82 degree and 30 minutes divided by 15 equals 5.5 hour, which means as India is east of Greenwich, Indian Standard Time is plus 5.5 hours to Greenwich. If the time of Greenwich is A, Indian Standard Time will be A plus 5.5 hours. Look at the screen and understand it. Some questions are given here. Try to answer it based on the directions given. There is answers to the letters given in red color are answers, and this is the end of the chapter. Thank you very much.